Start with a simple question. How does matter change from solid to liquid to gas? This process is called change of state, and it's one of the most important concepts in science. Imagine holding an ice cube in your hand. After a few minutes it starts turning into water. Leave that water on a hot stove and it becomes steam. These transformations are happening all around us every day, and understanding them helps us see the world in a whole new way. Everything around us is made of tiny particles called molecules. These molecules are always moving even if we can't see them. The way they move and the amount of heat energy they have decides whether a substance stays solid, liquid, or gas. When heat is added, these particles gain energy and move faster. This basic principle is at the heart of every change of state. Melting is the process where a solid turns into a liquid because of heat. Take ice as an example. In a solid, particles are tightly packed and only vibrate in place. When heat is added, the particles gain energy and start moving faster. Eventually, they break free from their fixed positions and begin to slide past each other. That's when ice melts into water. This transformation is a perfect demonstration of how heat changes the state of matter. Every solid has a specific temperature at which it melts. This is called the melting point. For ice, the melting point is 0 degrees C. When the temperature reaches this point, the solid particles have enough energy to break free and become a liquid. Understanding melting points helps us predict when and how substances will change state, which is useful in cooking, manufacturing, and even nature. Boiling is the process where a liquid changes into gas after getting enough heat. When water is heated, its particles move faster and faster. At around 100 degrees C, the particles gain enough energy to escape into the air as steam. This process happens throughout the liquid, forming bubbles. That's why boiling water bubbles rapidly. Boiling is a dramatic change of state that we see every time we cook or heat water. Temperature at which a liquid boils is called the boiling point. For water, this is 100 degrees C. At this temperature, the particles in the liquid have enough energy to break free and become gas. The boiling point is different for every substance, and knowing it helps us understand when liquids will turn into gases. This concept is essential in chemistry and everyday life. Evaporation is also a liquid changing into gas, but it happens differently from boiling. Unlike boiling, evaporation can happen at any temperature. Only particles at the surface of the liquid escape into the air. This gentle process is happening all the time, even when we don't notice it. For example, wet clothes drying in sunlight or sweat cooling your body are both results of evaporation. Evaporation is everywhere around us. When puddles disappear after rain, when wet clothes dry in the sun, or when sweat cools our bodies, evaporation is at work. It's a slow and steady process that helps regulate temperature and keeps things moving in nature. Understanding evaporation helps us appreciate the hidden science in everyday moments. Evaporation happens faster when certain conditions are met. If the temperature is high, wind speed is greater, or the surface area is larger, evaporation speeds up. For example, clothes dry faster on a windy day and puddles disappear quickly when it's hot. These factors play a big role in how quickly liquids turn into gases in our environment. Changes of state are happening everywhere around us. Ice melts in drinks, water boils for cooking, clouds form from evaporation, and steam engines use water vapor. These processes are essential for life, technology, and nature. Understanding them helps us see the connections between science and everyday experiences. When you add ice to a drink, it slowly melts, cooling the beverage. The heat from the drink transfers to the ice, causing the solid ice to turn into liquid water. This simple act is a perfect example of melting in action. It's a process we use every day to enjoy cold drinks, and it's all thanks to the science of change of state. Boiling water is a common step in cooking. When water reaches its boiling point, it turns into steam, which cooks food and sterilizes surfaces. The bubbles you see are water molecules escaping as gas. Boiling is a powerful change of state that makes cooking possible and safe. Clouds are formed when water evaporates from lakes, rivers, and oceans. The water vapor rises into the air, cools down, and condenses into tiny droplets, creating clouds. This cycle is a key part of the water cycle and shows how evaporation connects to weather and nature. Steam engines use water vapor to create movement. When water is boiled, it turns into steam, which pushes pistons and powers machines. This technology changed the world and is a great example of how understanding change of state can lead to innovation. Matter exists in three main states: solid, liquid, and gas. Each state has unique properties based on how the particles are arranged and how much energy they have. Solids are tightly packed, liquids are more flexible, and gases are free to move everywhere. Understanding these states is the foundation of learning about change of state. In solids, particles are tightly packed and only vibrate in place. This arrangement gives solids their shape and strength. When heat is added, the particles start to move more, preparing for the change to liquid. This structure is what makes solids unique compared to liquids and gases. In liquids, particles are less tightly packed and can slide past each other. This allows liquids to flow and take the shape of their container. The energy in liquids is higher than in solids, making them more flexible and dynamic. Gases have particles that are far apart and move freely. This gives gases no fixed shape or volume. The energy in gases is much higher than in solids or liquids, allowing them to spread out and fill any space. Heat energy is the key to changing states. When heat is added, particles gain energy and move faster. This movement allows solids to melt, liquids to boil, and gases to form. Without heat, these changes wouldn't happen. Melting isn't just for ice cubes. Snow melts in spring, glaciers melt in summer, and even metals melt in factories. This natural and industrial process shows how melting is a vital part of our world. Boiling is used in cooking, cleaning, and even making electricity. When water boils, it turns into steam, which can be used to power turbines or sterilize equipment. This everyday process is a powerful example of change of state. Evaporation plays a big role in weather. Water evaporates from lakes and oceans, rises into the air, and forms clouds. This cycle is essential for rain and climate, showing how change of state affects the environment. Evaporation helps cool things down. When sweat evaporates from your skin, it takes heat away, making you feel cooler. This natural cooling process is used in air conditioning and refrigeration too. The larger the surface area, the faster evaporation happens. That's why puddles dry quickly when spread out and clothes dry faster when hung up. Surface area is a key factor in how quickly liquids turn into gases. Wind helps evaporation happen faster. When air moves over a liquid, it carries away the escaping particles, speeding up the process. That's why clothes dry quickly on windy days and puddles disappear faster. Higher temperatures mean faster evaporation. When it's hot, particles have more energy and escape into the air quickly. This is why puddles dry up faster in summer and why drying clothes is easier on warm days. Evaporation and boiling both turn liquids into gases, but they work differently. Boiling happens throughout the liquid at a specific temperature, while evaporation only happens at the surface and can occur at any temperature. Understanding the difference helps us see how liquids behave in different situations. Change of state is everywhere. Ice melts in drinks, water boils for tea, puddles evaporate after rain, and steam powers engines. These examples show how science is part of our daily lives, making things work and keeping nature in balance. Industries use change of state for manufacturing, cooling, and heating. Melting metals, boiling chemicals, and evaporating solvents are all part of industrial processes. Understanding these changes helps create products and technologies we use every day. Nature relies on change of state for weather, water cycles, and life. Melting snow feeds rivers, evaporation forms clouds, and boiling hot springs shape landscapes. These natural processes keep the planet running smoothly. Technology uses change of state in cooling systems, heating devices, and engines. Air conditioners rely on evaporation, heaters use boiling, and steam engines harness water vapor. These innovations show how science and technology work together. Our bodies use change of state for cooling and hydration. Sweat evaporates to cool us down, and melting ice helps us stay hydrated. These processes are essential for health and comfort. Scientists study change of state to understand materials, weather, and energy. Experiments with melting, boiling, and evaporation reveal how the world works. This knowledge leads to new discoveries and inventions. Learning about change of state helps students understand chemistry, physics, and biology. Experiments with ice, water, and steam make science fun and practical. Education builds a foundation for future scientists and innovators. Environmental changes rely on melting, boiling, and evaporation. Climate, weather, and water cycles are shaped by these processes. Protecting the environment means understanding how change of state affects nature. Energy is transferred during change of state. Melting absorbs heat, boiling releases steam, and evaporation cools surfaces. These energy changes are important for science, technology, and daily life. Innovators use change of state to create new products and solutions. From cooling devices to steam engines, understanding these processes leads to breakthroughs. Science and creativity work together to solve problems. Artists use change of state in painting, sculpture, and design. Melting wax, boiling colors, and evaporating solvents are part of creative processes. Science and art combine to make beautiful works. History is shaped by change of state. Steam engines powered the Industrial Revolution, melting metals built civilizations, and evaporation shaped agriculture. These processes have changed the world. The future will use change of state for new technologies and solutions. Renewable energy, advanced cooling, and innovative materials all rely on these processes. Science continues to explore and improve our world. Society benefits from understanding change of state. Clean water, safe food, and comfortable homes all rely on melting, boiling, and evaporation. Science helps improve quality of life for everyone. Safety depends on knowing how substances change state. Firefighters use water to cool fires, engineers design safe boilers, and doctors use evaporation for cooling. Understanding these processes keeps us safe. Fun activities use change of state too. Making ice cream, boiling pasta, and watching puddles disappear are all examples. Science makes life enjoyable and interesting. Curiosity drives us to explore change of state. Asking questions, doing experiments, and observing nature help us learn. Science is about discovering how the world works. Change of state is a powerful concept that shapes our world. From melting ice to boiling water and evaporating puddles, these processes connect science, technology, nature, and daily life. Understanding change of state helps us appreciate the magic of matter and the energy that drives it. Science is everywhere, and change of state is one of its most fascinating wonders.